Okay, this is Lab 6 for AGEC 305. We are in week 9, and this replaces our Friday class meeting. So you have a reading this week. It's section 7 of that handout that was posted, that PDF that was posted, which focuses exclusively on incidents, or the idea that we introduce a tax in a market and it has different incidents on different impact on different members inside of that market. And so that's going to be our focus. In these PowerPoints, I'm mostly just going to show you the key parts, the key math from that handout, and of course you can go and look at these equations and read the description that goes with them in the handout. And then in the second part of this video, I will just show you how to fill in your spreadsheet so that it works to do the analysis for you, to do the same thing that you could get solving these problems algebraically. Okay, so let's see if we can, yes. So the first thing is an equilibrium model with no taxes. So we have a supply equation, a demand equation, and then this equilibrium condition, or the market clearing condition. Once you say that supply and demand quantities are equal, then you end up with only one variable, the Q star. We put the star there to say that's the balanced out version of the quantity. Substituting, we end up with A plus BP, the supply right hand side on this part, the demand right hand side here, and then our goal is to solve for the price. Okay, so you collect terms, factor out the price, and solve, and this is that final solution. So when there's no tax, we have an equilibrium price, P star, that is equal to the intercepts, the difference in the intercepts divided by the difference in the slope of supply and demand. Okay, so we've seen this before, we've solved for this, you know how to do it, and that's part of the formula that we should expect to see in our incidence equations. Okay, it showed up when we did shocks. When we talked about shocking, if this was the equilibrium market price for pork, and we talked about a shift that came from the beef market, right? Something happens in the beef market that causes beef to become more expensive. Then we had this component, this intercept versus slope component, in our price analysis equation, and then some adjustment that happens to the price, to the market price, due to those external effects, those external shifts coming from outside the pork market. Well, this is very similar to that. We're going to try to come up with sort of a core price component and the effect of taxes. The one big difference here, taxes have different incidents. So the beef market, the beef price changing, causing an adjustment in the pork market, everybody sees the same shift. Everybody sees the same impact of that higher price for beef. Not so when we put a tax in the market. What we're doing now is, instead of shifting supply or demand, we're putting a wedge or a gap between the price paid by producers and the price received by producers and the price paid by consumers. And so to handle that, we add a variable. So when we change our supply equation, it'll be the producer price, so P sub P. And in the demand equation, they were going to respond to the consumer price, or P sub C. Everything looks the same. These two variables are different now. But when you add a variable in general, in algebra, you remember we have this condition. We need an equation for every unknown to be able to solve. And so if we had 3 equations here before, 7.1 through 7.3, and 3 variables that we could identify, QS, QD, and P, well, when I split these prices out and say the producer price is different from the consumer price, we have now we've added a variable, and we need to add an equation for it. And that's just this linking equation that says the consumer price and the producer price are linked by that gap, or that wedge, and here we're going to call it TC, or the consumer tax. I call it consumer tax but it is an incidence equation, so it really doesn't matter who has to pay, who gets the bill for the tax, because the market adjusts so that everybody pays some portion of the tax. Okay, so this thing solves just like you would expect, except there's an additional step, and the additional step is to get rid of equation 4 by understanding that the consumer price is defined in terms of the producer price and this exogenous tax variable. This tax has to be given to you. Somebody has to tell you how much the tax is, or otherwise we don't know how to do any of the work. And so that means we can substitute the right-hand side in here for everywhere that we see the consumer price, and we'll be able to solve 3 equations and 3 unknowns the same way we've been doing. Okay, and so that's what happens here in the first step. So substitute the price linkage into the demand equation, so you end up with this new version of the demand equation where it's now the slope of demand multiplied by everything in brackets here, the producer price plus the tax. Now we can use the market clearing or the equilibrium condition to set supply and demand quantities the same, and you have this and same approach as before, but now our target variable to solve for is the producer price. Collect the terms and put them on the left hand side, and then we end up with this solution. So the producer price is going to be equal to our P star solution right here, the no tax price, plus some impact that happens due to the tax being applied. And so we end up with this coefficient, the demand slope, multiplied by the tax level divided by the difference in the supply and demand slope. So the same denominator applies in this this second term. We know D has to be less than 0. TC is some positive value that tells us the size of the tax in dollar terms, or in the same terms as prices are given. And so it must be the case that producer prices will be lower than the equilibrium with no tax. Right? So if this is P star, this is some negative term that tells you the producers under a tax are going to get some reduced value based on what they get when there's no tax. Here's the final write-up of that equation. So we substitute in, we say P star is equal to this coefficient, this incidence coefficient for taxes on the producer side. We need to recover the consumer price as well, because there's nothing here that tells us what it would be automatically, and so we can plug this in and we can see that we work through this. Of course, in a spreadsheet we can always just add the level of the tax to the producer price and get the consumer price, but we should go through the algebra here and see that if we substitute the solution value in for the producer price right here, then we can rewrite this as a solution that looks just like what we had above, and you end up with this consumer price is equal to the no tax equilibrium price plus some incidence factor. This time it's B over B minus D times the tax. Okay, and if you keep working through, so this figure shows up in part 7. If you go all the way to the end of part 7, you'll see that you can apply the same thing to producer and consumer surplus, a welfare concept that we're not going to spend too much time on in this class, but in your past classes in markets or even sort of principles of microeconomics, you probably saw that more. But the same impacts that show up on producer and consumer surplus will show up here for us in these price incidence equations. And so what we see here is for different levels of the tax rate, if the base equilibrium price starts at $20, if you apply a $5 tax, then this is the price that producers see, and a $10 tax, a $15 tax, and so this thing keeps going on. And then up here at the top we see the consumer price incidence. Okay, and so what is happening here is if $10 is the tax here, then the gap between the dotted line and the dashed line must be 10, right? The full tax must sit in between the consumer price and the producer price. So this is just a way of saying that the gap between these two grow. These are two linear functions, and so it's not unlike the alternate side, right? So we have demand equations that look like this, except they go in the other direction. So a demand equation looks like this. So it's sort of a mirror image of what we see. So while the demand curve moves down, the consumer price incidence curve moves up, and it moves up according to the ratio of the supply and demand parameters in the model, the slope of supply and demand. And so that's what we have. And so we'll be able to play with these a little bit and see them. So the task for us today in lab is to get you putting things in a spreadsheet. So build this model, answer a couple of questions, and then the next time we're in lecture, so we're going to build up your skill. I want to be able to use some different things that I've played with in this spreadsheet model to show you the relationship between supply and demand graphically, and these incidents, these measures of incidence and how they show up graphically. And we should be able to develop this intuition about how do elasticities or the slope of supply and demand relate to the impacts of a tax, so that under any condition where somebody tells us the right policy or a proposed policy in some market is to apply a tax, we should begin to understand, just by knowing something about that market, if we begin to understand the elasticity components on the supply and demand side, we should know pretty much everything we need to understand how a new tax, like a soda tax or a cigarette tax or anything like that, might function, and who will bear the brunt of it, whose price, who's coming out of the consumer market or coming out of producer profits. Where are we liable to see the bigger impact? So with that, we're going to switch over and pull up this week's spreadsheet. So you have a spreadsheet that looks like this. It's already filled in with some intercept slope values, and so really we just need to add this one equation, and it's that price incidence equation for the producers, and we can get everything else based off of that. So in this first column, we're going to call it the no tax column, and so we'll just put a 0 there. And so we need to build our equation out for the producer price. So what I'm going to do is put an equal sign and open with some parentheses. So I'm going to build it the same way I wrote the equation in the slides, or the same way it's written in the handout you have, section 7 of that handout that you have to read. It's the intercept of the demand equation minus the intercept of the supply equation, A, close those parentheses. Now we'll divide by, start a new set of parentheses, we'll divide by B, or the slope of the supply curve, subtract from that the slope of the demand curve, D, that's in cell C8, and we have our first component. That's the equilibrium price when there's no tax. We'll go ahead and add, even though we're going to make the tax be 0 in this version of this scenario for this column, we'll go ahead and add the other part so we can just copy all of our formulas. So it's plus, and if you look at that that tax factor, that incidence factor for the producer price, we need an open parentheses. It is the demand slope. It's the negative factor because producer prices get pushed down. They get smaller as the tax gets larger. So we get the demand slope divided by some open parentheses again, and now we'll take the supply slope minus the demand slope, that repeating factor that shows up. So B, C4 or B minus C8 or D. Close that parentheses, close them again for the other one, and so this first component is P star, this component is that tax incidence factor for producers, and we need to multiply that by our tax variable, which is down here in C14 under T. Do all that and you'll see a price of 50. So now for the supply equation, we need to just fill in the supply equation, and the supply side of this market responds to the producer price, so we'll have to use that particular price variable. So we'll just go equals A, or C3, plus B times the producer price. We have that component. Now for the consumer price, we could do the tax incidence equation. You're welcome to do it that way. But once we know the producer price and we know the tax, we know that it's just the addition of those two, right? So it's equal to the producer price plus, down here in C14, the tax variable. And now for the quantity demanded, the only real difference we have to deal with is, and before we had one price that both quantity supplied and quantity demanded responded to. Now the quantity demanded must be a function of the consumer price. So we put equals C plus D times the consumer price. So be sure you get C12 there. Alright, so we filled in all the formulas, and now we just need to highlight all these. I use Control C to copy, and then go over here and type Control V. You can drag it over however you want to do it. And so now we've got two columns that are the same, and so the way we want to make these things differ is by starting to plug in some different values for taxes in this column. And so the easiest thing to do is just put in 1, I guess. And so we start to see the impacts. So if we make a tax of 1, the producer price falls from 50 to 49.5. The consumer price goes up from 50 to 50.5. The quantity in the market falls, right? So a tax can't increase the quantity in the market, and in general it will lower the quantity of exchange in a market. If you continue to adjust this, I guess I should point out the other columns that are being calculated for you. So this column is the change between scenario B and scenario A due to the tax that we're applying in this column here. So this one's always going to be 0. This is our reference column. This one is always going to be some non-zero value, and this will compare those two. Okay, and so if you continue to change the tax in this column, you'll see the impacts, and so what you start to see is that these numbers keep lining up. They keep staying together, and if you go up here, you'll see that we have a slope of 1 for supply, a slope of -1 for demand. Those two things are stuck together as well. And so what's really going on is those, as you saw when we solved for those incidence equations, these incidents, these terms out here, the impact on producers or consumers, is built from D and B, and comparing D and B to their total, right, to their sum in absolute values. And so what you're getting here is the negative impact on producers depends on how big is D relative to B minus D, and on this one is how big is B relative to B minus D. So these incidents, this burden that I'm calculating down here as the share, right, how the tax is for, how much of it is increased price for the consumer, how much of it is lower price for the producer. That's what's being calculated down here. So if you look at the formula here, it's E10, the impact felt by the producer, divided by E14, the total impact that we're applying to this market. Same thing here. So it's E12, the impact on the consumer, divided by the total impact. So those don't change. So the only way to change those would be to come up here and say, what if now the supply slope is double in absolute value the demand slope? And you'll start to see some of these impacts happen, and we need to make adjustments here. Alright, so you start to get the relative size of these things. So the burden of the tax here is not quite calculating to what I thought it would be. Oh, sorry, you have to change. So I've set this up poorly for you. These were supposed to be triggered by these. So when you get your spreadsheet, I'll have that fixed for you. So the column B is supposed to adjust every time. The stuff up in blue is supposed to adjust every time you adjust this. So there we go. So now you're seeing that it's negative 1/3 and plus 2/3. Sorry for the mistake there. So when I give you this spreadsheet, I'll fix this for you so those will adjust automatically for you, and you can continue to see. And you'll just be able to go in and change these taxes to however you want, or come up here and say change something in column A like this, and now we've switched it back so the producers have the bigger impact. And of course the moral of the story is whichever is the smaller in absolute value of B and D is going to have the bigger burden of our tax. So with that, we're at about 20 minutes. It's about right. And I want you to spend a little time looking through section 7 of the handout that's posted, and then you'll have a lab quiz attached to this that you can answer some questions using your spreadsheet. There'll be a couple where you just plug in and get the values, but also some where you just where you're also asked to sort of consider some of the concepts. And good luck with it, and that'll be our lab for week 9.